our lipid structure. Finally, we are going to use this information in clinics with analyzing this lipid panel. We know we need those things as one of the sources of diets for energy, and some of these factors like see lipids, or here lipid profile. For lipid profile, we are going to see these things: cholesterol, HDL, LDL cholesterol, and triglyceride. Triglyceride is a storage form of the lipids, and you can find all of this information in laboratory tests. And we started with the fatty acid structures. These are CH2, 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 all of them. And this is a palmitic acid, 16 carbon. We're just going to learn 5 or 6 fatty acid name and their differences. And we had some unsaturated, monounsaturated, and polyunsaturated fatty acids with double bonds. So these polyunsaturated fatty acids are more dominant in plants. Fatty acids in plants, they are in unsaturated form. Because these saturated forms are solid, and in a plant structure, it's not applicable having those kind of lipids. And how we produce this, saturated fatty acids from these unsaturated ones? Yes, adding hydrogen to industry, we do that. But in animals, they already synthesize this one. Have you tried some butters in Iran? Butter.
Butter?
Yeah.
Going on the roads?
Do you know some brands?
7.
7, yeah. Park. Another one is Park. Today morning I was trying to, eat some butter. I checked it. It had cow on it. It says it is from, animal sources. In otherwise, you might see the name of margarine. Margarine, actually, the mainly are this, and they are saturated to this one. And they try to mention the resources of that, plant resources or animal resources. And for the putting number on it, you had a structure like this, and first numbering starts from the carboxyl groups 1 and so on, amino. In other types of that, we have nutritional, actually nomenclature is that starting from the last methyl group is omega. Omega 1, omega 2, and nutritionally we had some important ones like here. What is the omega? Omega 9. But nutritionally, some polyunsaturated here, omega 3 or omega 6 are great, specifically omega 3s. Some names and some two essentials, linoleic acid, linolenic acid, some of those essential because they have more than one double bond. They are polyunsaturated fatty acids. However, arachidonic acid in some books before double bonds is called essential, but we can synthesize that from these 3 bonds, linolenic. And desaturation happens. We have a desaturated enzyme converting this saturated one to unsaturated one. And the difference between the trans and cis bonds. In vitamin, you are going to see that converting these ones to these ones are fatty acids. Help us to see everything just with that one, or adaptation. When you go in a dark place, at the first one, you don't see many things there. But it takes time You see many of those things. And yet, it's a kind of changing between trans and cis in just vitamin A structure. It has a lipid structure like this. And we had this hydrogenation converting, you know this process. This is unsaturated to saturated one. But during this hydrogenation, we had a chance to watch production of this transport. And even just a small amount of these things cause some kind of high LDL level. And this is the hydrogenation process, you know that. And the famous one, famous code. So we started with two groups of the lipids, phospholipids, glycerolipids. It says the base is alcohol in glycerolipid is glycerol, like this, we have this, and three fatty acids to that. This is the 3-hexylglycerol storage form. But we know the storage form is a one form of the fats. We have other forms of the fats, like here. We'll be back to this one at the end. But see, this is an overview of that. I'm going to focus one by one in the next slide. Like this. We have a fat glycerol, but we know we can actually replace this fatty acid with one phosphate. Remove that, add in phosphate. Phosphate is a hydrophilic compound. It helps, we have a hydrophobic and hydrophilic structure. And it helps for what? Putting these phospholipids on membrane, cell membrane. Because some sides are water, other sides are, lipids or some other structure. And these different types of the phospholipids you see. Another alcohol was sphingosine. We have a sphingosine here. It also has, this is alcohol, another fatty acids on this structure, and some sugars or alcohols or amino acids can connect to this phosphate. For example, phosphatidylate, the sphingosine, phospho, and choline is called, what is this? You see, this is a choline, this is a sphingosine, this is fatty acid, this is a phosphate, it's called sphingomyelin. Sphingomyelin is present where? In membranes of specifically nervous system. And different types of these sphingolipids. Sometimes we have a carbohydrates on this structure. Mainly this is some of these carbohydrates are in our blood groups, like A, B, O blood groups. Actually, they come from the carbohydrates. They are connected to the sphingolipids. Or some others, we have several types of those things. The changing these sugars, we have different types of. You see some information here, you are going to read those things. And the second nut, I can't say second, another group after lipids. What are the another group? Esters. We have two types of esters, phytoesterols or animal sterols. We are going to study these ones. In animal sterols, we call them cholesterol. We have several derivatives of cholesterol. Cholesterol can synthesize a lot of things. One of them is bile acids. See, the structure is same to cholesterol. This is the cholesterol structure. This is the bile acid. What is the importance of the bile acid? Yeah, it helps to absorbing lipids or digesting the lipids. Without them, we can't absorb lipids. If you consume lipids, without this cholic acid, we can't actually absorb them. And also vitamins. Fat-soluble vitamins. And some hormones. Steroid hormones. Do you know some of them? Read them, just read them. Yeah, we have some of them. Right? Sex hormones, testosterone, progesterone, estradiol, and vitamin D. See, calcium is a vitamin D. our vitamin D comes from the cholesterol, from our skin. Because of that, we are recommended for sometimes be in front of what? Sunlight. To receive enough UV light to convert, this cholesterol to vitamin D. Otherwise, you have to take some pills. It depends on you, which one. You are going to rely on chemist or sun. So, yeah. It is better change your relying pathways. Yeah, it is better rely all the time on natural processes. So, we stopped here. So cholesterol level. Cholesterol level, we have some diseases related to high cholesterol. What are those diseases? Most of the time you receive some recommendation, someone says, don't eat that one, it has high cholesterol and you're going to get fats or something like that. So what is the main reason for the high cholesterol actually toxicity, let's say? Yeah, atherosclerosis. So what is the atherosclerosis? It's a kind of changing in vein. And this is a cell membrane. This is a cell membrane. And you can see we have what are these? Phospholipids. There are phospholipids. But between phospholipids, we have some cholesterol. Without the phospholipids, our cell membrane is going to be like this. Let's say. They are not tight. But cholesterol structure is tight. And we have some cholesterol between these phospholipids. And it helps that it works like this. It's not so liquid shape. So it has kind of, tightness, enough structure. How about we have more cholesterol? What happens? It's going to be like this without any enough actually solubility. So if it happens on vein, what happens in vein, we need to change the diameter of them in blood pressures, open it or tighten it. But with high cholesterol, it never happens. It's going to be like this. And because of that, blood pressure goes up. And then we actually need to decrease the blood pressure. We need to open this vein or just strengthen them. And then when the cholesterol is high, they are not going to be like this. They will stay like this. So cholesterol level is critical. Low level cause the cells actually membrane actually without it seems they are not tight, they are loose and everything can pass. And high level can cause some tightness of that. We need an optimal level of cholesterol in cell membrane. And in other places, we synthesize many things from the cholesterol. But in cell membrane, that is essential. See, liquid one and gel one. When we have a low cholesterol, it's a kind of jelly structure. So it's not. So, based on that carbohydrates, can you study these things? Can you explain what is the differences between different blood groups?
And change in the arrangement of the structure.
Based on this structure, we have what is this strand? That alcohol. And we have a fatty acid on this. Alcohol, fatty acids, all the time. We have this combination. And here we have a carbohydrate. What is the, for example, let's say A antigen. What is the blood group A? We have some carbohydrates here. You are not going to supposed to know what are these. Otherwise, you'll be a specialist in hematology or something. You are going to study those things. But here, we are going to say we have some sugars here, carbohydrates, or oligosaccharides, because they are more than 2 carbohydrates. And what's the last one? Then acetyl galactose M. What is in B group? Just galactose. Then you add N acetyl to this galactose, you change blood group from B to A. How about O blood group? You don't have the last one, this one. missing the last sugar. See? Just one sugar says you are O, positive O, just O. It's not going to say positive and negative because all positive and negatives comes from other antigen, RH antigen or RH antigen. Yeah. See? Just one sugar, not just one sugar, just one in acid here. Differences between two things. Just acetic amine. Different protein. What is this? This is a glycerol part, this is a phosphol, this is the inositol. We call this is the phospholipid. We have some enzymes, they act on these phospholipids. What are they called? Phospholipids. Great, that is so easy. What kind of phospholipids are present? Different types. First one acts on the carbon 1 on first structure, we call it phospholipase A1. How about the second one? A2. How about this position? C. In this position, we call it phospholipase D. They digest these phospholipids. So you might think, what are those? Let's say this is inside the cell. And in blood circulation outside, some of these hormones actually wants to come to the cells, but they can't. You know, the protein structure, actually hormone, they can't actually come inside. They can actually knock the door and start what? One enzyme here. That enzyme one of that enzymes for insulin is phospholipases. They activated this one, and in this, let's say this is a phospholipid and this membrane. They digest, activate that enzyme. That enzyme acts on the phospholipids and remove part of the phospholipid. Remove this part, or remove this part, whole part. All of these things are secondary message. They are come inside the cells and start working with the others, or just sending that message. They say, insulin told us start doing that. They are called secondary messengers. So these are in cell membrane. So see, they are used as a structure, and at the same time they can be in a specific messenger pathway. And we have different types of the phospholipases. One of them is involved in pain. This part. Phospholipase A2. Yeah, in pain and redness or some trauma, this one starts working and remove this fatty acid. This fatty acid goes to prostaglandin. Here. See, this is a phospholipase A2. Remove what? We call them prostaglandin and leukotriene. What do you think about these leukotrienes? Can you actually find the meanings for the words? Leukocyte, yeah. It says they recruit leukocytes. When you hit an area, hit by something, or have a trauma, our immune cells should come there. Phospholipases start working, remove this one. See, this fatty acid. This fatty acid actually is one of these. Phospholipase acts on this and removes this. This is here. And it goes to producing what? Something, some of those things. One of those things are prostaglandins. See prostaglandins. What are prostaglandins? Cause inflammation and pain. So if you want to stop pain, what do? Use that drug. What was that? Ibuprofen. Acts on what? Cytotoxin. We stop this fatty, our drugs. We have an enzyme here, goes on this arachidonic acid. This is arachidonic acid most of the time. And produces this prostaglandin. If you stop these bonds, you stop pain pathway or redness or a lot of things that triggered by that one. So, and also aspirin works on here. both of them works on this enzyme. So see, we produce prostaglandin from what? What do you mean now? One fatty acid. What is that fatty acid? Arachidonic acid. See, the process are here. Some of those things, see, these prostaglandins and leukotrienes, actually they have a problem. Toxicity, edema. You are not going to study these things, but you are not supposed to study and memorize these things, what happens in trauma or something, just as a whole concept. Precursor of the prostaglandins are fatty acids. What fatty acid? Arachidonic acid or arachidonic acid is one of them. And another thing here, this enzyme, cyclooxygenase, is involved in production of these prostaglandins, are inhibited by some of these drugs. That is enough for this process. And also, we have some drugs, they can inhibit this phospholipase A2 also. To stop actually outside of this process. What is this? What do you think about this? Yeah, you can read this one. You can read this one. This is a venom snake venom. So, what is the enzyme? Phospholipase A2. See, this snake uses this phospholipase A2 as a weapon. What happens when they actually bite someone? These phospholipase A2s actually aggregate membrane. They aggregate your blood. So these phospholipases acts on the lipids of red blood cells. You know, if you try this, video in YouTube, you are going to see that they have a, blood cells on this, and they try to inject that venom, then actually bites that, this membrane and release that toxin on it, and you will see the aggregation of these cells. So they aggregate, they kill actually animals or some others by this phospholipase A2, because this phospholipase causes, in a toxic level, it causes aggregation. It is the same for the producer for the prostaglandins, the cyclooxygenases. We use what? What are these? NSAID. You are going to use this word a lot of times. What are the NSAIDs? Non-steroid anti-inflammatory drugs. We have two types of the drugs for the inflammation, to stop inflammation. Steroid ones, non-steroid ones. Mainly we use non-steroid ones because steroid ones stops immune system. So this ibuprofen, ibuprofen, they are called NSAID. They are called NSAID or non-steroid anti-inflammatory drugs. You are going to study those things in pharmacology or pharmacy parts that you are going to learn those things. But everywhere that you see the NSAID, they might say NSAID. Please take NSAID. It means the diclofenac or ibuprofen or ibuprofen or all of those things that reduce your pain. Mainly they are NSAIDs. And the same one. We are going to talk about
Painkillers.
sorry.
Painkillers.
Yeah.
They are answers.
Yeah. For this one, this NSAID, see, stops the arachidonic converting to prostaglandin. What is the enzyme here? Cyclooxygenase. We just start this prostaglandin from one fatty acid. What is the fatty acid? Arachidonic acid. And vitamin A structure. We will talk about these vitamins. But as a lipid compound, we can talk here also. What is that? See, in vitamin A, the vitamin A present in animal resources. However, some plants, they have precursor of it. It says if you consume those vegetables like carrot, we can convert that precursor to vitamin A like this. This is a beta carotene. This orange color from this beta carotene. In many places, in many fruits, if you see this color, mainly that is beta carotene. And our liver can convert this beta carotene to vitamin A. And you might see we have different types of or different structures of this vitamin A. What is this? This is all trans, but we have also 11 cis. In just one position, we have just cis form of that. And that is the difference between this one. This 11 cis is involved in what? As a visual pigment. For the visual, we need to convert to this structure. So 11 cis. All trans to 11 cis. So, the last part of the lipids is called lipoprotein. What do you think about the terms of the lipoprotein? What's that? So easy. Lipids is proteins. So why do we have lipoproteins? What do you see here? What is the structure or the spiritual structure? Exactly. It seems. What was the main properties of lipids? If you define them. Main properties, physical properties. They are soluble in water. So how they are transported in blood circulation? If they are not. Yes, exactly. You say, I'm going to package them. I put something that is soluble in water outside, and inside that, we will have our lipids. We call this structure lipoprotein. That's a clever idea. So, if you look at this is the spherical form. Outside of this spherical forms, we have a phospholipids. These are phospholipids. See? Phosphate parts and lipid parts, fatty acids. See? What is this non-linear? What is this linear? Unsaturated fatty acid. Unsaturated fatty acid we have. Is it this cis-trans? What was the transform? It was the soul without Ben. But in
hydrogenation.
Yeah, in cis we have some Ben. It helps to jelly force or mobility or kind of elasticity of these membranes. And what is this? This is structure cholesterol. Cholesterol. It's the cholesterol structure. It's some 4 rings. Everywhere that you see these 4 rings, that is a cholesterol. And there's some branch on it. What is this? Triglycerol, triglycerol. So, what is this? The fatty acids bonds to cholesterol. We call them cholesterol ester. Cholesterol, fatty acid. Bound together. Or cholesterol ester. Everywhere that in the book, if you see the cholesterol ester, it means cholesterol plus fatty acid. It's not just free cholesterol. Otherwise, they mention free cholesterol without this fatty acid. And what are these? Outside? Proteins. Yeah. Because of that, we call them lipoproteins. We have some proteins outside of that, and that proteins helps solubility, and there is a kind of sign to them where they go. It says you can go, for example, if you have a trolley, and like let's say this lipoproteins are like trolley, if they have a sign on it, some of them should go, let's say, in the lab. Some others actually should go other place. They have a sign. It's like these proteins help them to go different places. What are the lipoproteins? Different types of the lipoproteins. There is a story for this one. I'm going to talk about that one here, but we will learn this with many details in metabolism. But for the lipoproteins, I have to explain it here. When you consume, every time when you consume lipids, what happens? Our enterocytes, let's say these are, I'm going to write these are enterocytes. This is our intestine. And what are these? Why do we call them enterocytes? Because they are our intestine. In enterocytes, when we absorb them, absorb lipids. I'm not talking about how we absorb those lipids, but you know with bile acids we help them to absorb them. Let's say we absorb fatty acids. Glycerol. In triacid glycerol we have this thing. This one and this one. And also what? Cholesterol. I'm going to write cholesterol as a C. And some other fat soluble. What? Vitamins. A?
Vitamin A, B.
Oh yeah, all vitamins. Vitamins. A, D, E, yeah. A, B, E. Is there anyone coming here? No. That there is that's soluble. I was thinking, is there anyone? I'm forgetting that. No. So, all of these things in the enterocyte, I'm going to make this enterocyte a little bit bigger. So, when you have all of these lipids, can you release these lipids to blood circulation? No, you can't. If you release them, what happens? You have a blood clot. How do you actually, can you store them here? No. In enterocyte, you can store that, those things. You have to get rid of these things or send them where? Yes, exactly. Everything that you absorb, where do you send? Liver. Everything, drug, sugar, carbohydrate, protein, everything that you get in the cells, absorb them, and then send them to, I'm gonna draw two different types of the transporting. Have you heard about the different digital terms? Lymphatic vessels. What is this thing? And interstitial fluids. Yeah, exactly. Let's say we have a main corridor. Our corridor is a vein. But when these cells, receive some liquids, might they have some extra liquids they can go to the main corridor. We should have some, alternative corridors that are backside of the cells collect those things. And have you been in some cities? They have a specific way for some fast, bus tracking or specific ways for some, cars. They transfer everything so fast. The lymphatic system or vessels are for collecting interstitial fluids and also circulating immune cells so fast. In lymphatic system, we have immune cells, they are already there, and they are ready to start fighting. It's a kind of reservoir for our immune cells. They are already there. But we have a specific ones in blood circulation also. But those that we have there, they already know what kind of antigen, they can recognize that and they can attack that. However, in blood circulation, we have different types of them. So, this lymphatic system is essential for transporting what? These lipids, exactly. We are not going to send them one by one to this vessel. We package them. What does that package need? Kylo, micro. This. See? This is large. Why this is large? Because it is full of free acid. This way we convert these two ones to TAG and insert to this TAG. And it has some cholesterol and some cholesterol in membrane or some cholesterol ester. These are less than 3 acid cholesterol. And some proteins are in it. I'm just going to write protein here. I'm not writing the specific protein name, but here is called P14A. Mainly. We synthesize this one. It has a lot of lipids. When you consume lipids, we have packaged them and send them to the lymphatic system. And this lymphatic system goes to where we have a specific, let's say, our liver. They transfer this lipoprotein to the liver. What happens in the liver? It opens that and remove everything. It says, thank you so much, you send everything here, but I'm going to make a decision. What happens to those lipids? It makes own packaging, new packaging. Remove everything, deassemble everything, and synthesize what? Another lipoprotein. I'm going to show it smaller than this one because the size is smaller than chylomicrons. Also, we have mainly 3 acid glycerols and cholesterol ester, and also phospholipids on these membranes, and some proteins. The proteins is called ApoB. Protein ApoB100, main protein. However, we have some other protein, but I'm not sure. What happens when liver synthesize this one, release it this time to our blood circulation. Now it can go to blood circulation. When you consume more lipids, you produce more chylomicrons with a lot of fats. During this movement to the liver, what happens? Some tissue gets some of these fatty acids. Thank you so much. Can you give me some of these fats? What happens? They are deposited or collected on these areas or some other areas. So because we have some enzymes on this lymphatic pathway, we are called, what is this? Lipoprotein. What's the enzyme for that? What do you call it? Lipoprotein lipase. LPL, or lipoprotein lipase. Acts on these ones and removing, just biting some of these fatty acids. And those fatty acids goes to the tissues around that lymphatic system. We have a digestive system in our intestine, and so when we absorb them, the lipoprotein lipase acts that and absorb some of those fats and collect it in this area.
Or activity.
How about this one? When we release this one to the blood circulation, we also have this enzyme also in the blood circulation, glycoprotein like this, acts on this VLDL or this big one. What's happening to this? Getting smaller, smaller, smaller. Why? This type of protein lipase acts on this, remove what? Fatty acid. Remove fatty acids. This fatty acid goes where? Muscles. Need that one. In blood circulation, you are circulating and giving that fatty acid to the cells. Here you are. You can consume this fatty acid. If you don't need that, storage that. So it is getting. Thank you so much. You saved us.
Yeah. Very helpful.
Oh, yeah. When is your last class? Not just very close. No, I mean for this semester. For this semester. June. You started late. Yeah.
Last examination or last class?
For last class, I mean. For the exam, it's okay. But for a long time in the class, it's yeah. And with these subjects. Yeah. So, what happens to that? It's getting smaller because removing some fatty acids, but I put protein like this. What do you call this one? LDL. However, we have another term. What is this? Intermediate DL or intermediate density. We are gonna see the whole name by color. So we can, for this one, we can call them IDL or intermediate. But this one is DL. And this one is full of in cholesterol. It has a lot of cholesterol, LDL. And it circulates in blood circulation. Let's say you have some guys, all the time they are circulating in this, corridors. They have cholesterol. And liver can uptake them and synthesize new LDL. And then those LDLs are replaced with new LDL and synthesizing new LDL. All the time we have these proteins in blood circulation. If you take a sample from yourself, you will find this, except the chylomicrons. If you be fasted for 8 hours or 10 hours, you will not see that chylomicrons in blood circulation. Because our liver actually clears them after some hours. But the other ones, then in other cases you will see. You will see this one's blood circulation, and also this one's. And what is this? HDL. What is the HDL? You are going to see that. So you transfer many of these lipids and cholesterol to the tissues. But some tissues, they say, I don't need this one. Specifically for the cholesterol. They say, I don't need this cholesterol. Why? That cholesterol, you saw that. In low level, it causes some jelly form. In high level, it causes some kind of, strict structure. So we don't have a specific pathway for storage of cholesterol. See, we storage lipids. What lipids? 380 glycerol. Do we storage cholesterol? No. They are toxic. We send them back to the liver. We say, this is yours. I don't need that one. Who is supposed to bring back to the liver that cholesterol? HDL. HDL takes the cholesterol from the tissues back to the what? Liver. So, what does liver do with this cholesterol? You might ask a question. What happens to them? If they accumulate in the liver, what happens to the liver? Liver knows what to do with them. Convert to bile acids. See, do you remember this bile acid structure from the cholesterol? And bile acids goes to the our intestine, helps by absorbing lipids. All 100% of the bile acids are absorbed? No. Body checks that, says if we need more cholesterol, absorb 98% of that. If we don't need them, let's 5% goes up. So it is the best way for controlling the level of cholesterol in the body. Our body knows how to balance cholesterol level. But for the lipids, it says, I can't do anything. If you consume more lipids, you are going to store it. I don't have any option because we store some of those energy we control. We can't extract energy from cholesterol. We don't have a specific. You might say, oh, that it has a structure of the carbon. Why we don't extract energy from that? We never extract energy from the cholesterol structure. We don't have system to open that, use that carbon as energy. But for the carbohydrate, if you see, they are carbon. They are same. But we can. We can extract energy from the carbohydrates like what? Sugar. But carbohydrates like, or fats like cholesterol, we can't extract energy. They should go out by bile acid. We absorb 95 to 98% of the bile acids. Why we have this interval? 95 to 98. When we absorb 95%, yes, then cholesterol is low in our body. When we actually high, when we absorb 98%, when the cholesterol is low, we say, I need that bile acid, I'm going to reuse it. I'm not going to convert in my cholesterol to bile acids. I'm going to use that one again and again, several times. So, just short review of this part. What it says we absorb lipids in intestine, converting and packaging to what? Chylomicron. Chylomicron go to the lymphatic vessels, and they are taken by liver. Liver deassembled and synthesize new lipoprotein. What is that? VLDL. Why do we call them VLDL? You might say very low density lipoprotein. Very low density lipoprotein. And our liver excrete or secrete these ones through what? Blood circulation. In blood circulation, they are circulating, and we have some enzymes, lipoprotein lipases, acts on this, remove some fatty acids, produce what? Low density lipoprotein. This one was very low density, this one is low density lipoprotein. And this circulates in blood circulation and be uptaken by tissues and liver. Extra of that are uptaken by the liver, but other tissues, if they need cholesterol, this is full of cholesterol. The cholesterol level is high. Have you heard about the bad cholesterol? We call this one bad cholesterol. In some books you might see bad cholesterol. This is the LDL. High LDL is a sign of high level of the cholesterol in your body, and it's not a good sign for your cholesterol level, because level of that shows you have high cholesterol in blood circulation. So, it is circulated through blood circulation, and it can be taken by tissues or the liver. And you might say, how about if we send more cholesterol to the tissues? What happens in the tissues for that cholesterol? You say if tissues need that one, use that one. Like hormone for synthesizing, or using the cell membrane of the cells. How about the extra of that? You are not going to storage cholesterol. What happens to that? Send them back to the liver. Say, you are going to know what to do with those things. I can't actually handle that. Exactly. We synthesize what? HDL. HDL in blood circulation is the same every tissue. Do you have extra cholesterol? and collecting data. You have all cells give their actually extra cholesterol to HDL. HDL collect all of those HDL cholesterols and give those cholesterol back to where? Liver. Liver knows what to do with it. What is the best way? Convert to bile acids. So, and then bile acids go to the intestine, and we have an interval for absorption of the bile acids. 95 to 98%. It depends on the level of the cholesterol. If we need more, we absorb 98% of that. If we don't need more cholesterol, we absorb 95% of this cholesterol. So, these are lipoproteins. However, in some groups you might see intermediate lipoproteins. Actually, that's some intermediate shape of this VLDL to LDL. It's just based on the shape. They say this is intermediate of that. Because it's not going to happen just VLDL converting to LDL. It's a kind of, transition. We have different sizes there. So, but it's not important. You just learn chymochrons, VLDL, LDL, and HDL. And the last thing here, what is the main component of the chymochrons? 3-acyl glycerol. 3-acyl glycerol. What kind of 3-acyl glycerol? Your diet or exogen. You get from your diet. What is the main component of the VLDL? Also 3-acyl glycerol. But what is the difference between this one, this 3-acyl glycerol, with this one? These are endogenous. You might synthesize this one from the lipids from your abdomen or extra fat that we have. So, he said the lipoprotein chymochrons has mainly 3-acyl glycerol. That 3-acyl glycerol comes from what? Exogenous. So, because of that, if you measure in your blood circulation, you see chymochrons, you are going to say that you weren't what? You weren't fast. That is exogenous. You had a meal yesterday, it was full of fat. Or it wasn't enough interval between eating time and taking the sample. It should be around at least 12 hours. But if this one goes up, what do you say? What do you expect? You say, you are not in a healthy situation. Your fatty acid is high, your triglyceride is high. Because it's a sign of 3-acyl glycerol on that person, not for that one meal, for whole lifestyle, for an actually period of time, not just yesterday. And how about this one? It shows level of the cholesterol, not triglycerides. It is more related to cholesterol level because it has less 3-acyl glycerol, it has more cholesterol. And how about this one? It's a good sign. If you have high of that, it says you have high protein, they are returning back that cholesterol from the tissues to liver to handle it or just stop going to the tissue. So these are the primary interpretation of these chymochrons or lipoproteins like I mentioned. And in your exam, you are just going to answer some basic questions about the lipoproteins. Which one has more exogenous 3-acyl glycerol? Which one of them has endogenous 3-acyl glycerol? This is the exogenous 3-acyl glycerol. This is the endogenous one. This is the high cholesterol of the or bad cholesterol. This is the also high cholesterol, but it's a sign of returning back cholesterol to the tissue. Because when you have those things, let's say if you see more HDL in the corridor, you say they are returning back that bad cholesterol to the tissues. So it's all interpretation you can have here. You can have 10-minute rest, and then we after this class, I hope you sometimes you look for some of these ingredients on the food. However, sometimes they try to hide this information and they don't write many things. However, in some countries, there are strict regulations for some industries. They write everything on their product to consumers' right is a protecting area. They support these things. For example, here see the partially hydrogenated vegetable oil. It's a partially hydrogenated one. There's a chance to have trans fatty acid. However, in some countries like Iran or some other countries, you might not see they actually saying that. They don't write that. And so you don't know how much of these fatty acids are trans. And monitoring this is another option. So you might be in some regulation places and you want to analyze these fruits that is kind of high technology and time consuming and expensive. And for some country, they prefer they don't write anything on these things and they say it's safe. Take it. It's good. And yeah. Directed? Every time I eat them, I count the number of the trans fatty acids that I get. And this is the whole things that you can look at that and see the trans fatty acids, saturated fatty acids, or unsaturated fatty acid resources. And yeah, it goes on. And finally, this month is for sources for vitamins A, D, E, the base resources for these vitamins. Yeah, this is the whole thing for this for the today's lab. The next part is going to be vitamins. But if you talk about the vitamins in 1 PM, we are going to have our lab, our experiments. I tried, for yesterday's experiment, I tried to find some myths, actually, that they are not, ultra pasteurized, not pasteurized. I tried to find that one, I couldn't unfortunately, but I'm going to find that and give to Dr. Hanani when he comes here to show you at least one of those experiments, how they work. So, yeah. But for today's session is about some techniques that we use